Good evening to all. Is the audio and video clear for everyone? Thank you. So, any queries with regard to the previous session for anyone on graphical method, on linear programming problem, what we have solved? Say, right? So, I am going to start today's session, and the objective of the session is actually the lecture was posted in the Telegram group link. You can access that. You can check the group once. Thank you. So the objective of today's session is on going for graphical method again and doing some more problems on it with different results, or you can view the graphical method in different contexts. The variations in graphical method in a simple nutshell, I can say. Later, one of our friends asked about the simplex method, limitations. So first of all, I am going to take the concept of simplex method problem solving. And after solving one problem, we are going to discuss about the limitations of simplex method. So that is all about our today's session I am going to plan. Clear? Right. So let us be interactive. So I am going to take the inputs from you as well, and let us do with some problems on graphical method first. So take the problem that maximize z equals to 10x1 plus 3x2 subject to the constraints 2x1 plus 3x2 is less than or equal to 18, 6x1 plus 5x2 is greater than or equal to 60, where x1 comma x2 are greater than or equal to 0. This was the problem. So usually we are going to draw the straight lines compared to the given inequalities. So let us go with it. So this is x1 and this was x2. So if you consider the first line 2x1 plus 3x2 equals to 18 as a straight line, so you are going to give me the points for it. What are the points to be taken for it? By substituting x1 and x2 equals to 0. Say, right? So the points are 9, 0 and 0, 6. Accepted to all? Fine. So let us draw them. Let me say it's better to take like this 2, 4, 6, 8, 10 and so on. So 9 will be here. The thing is 9, 0 and 6, 0. This will be the line. So what happens here? It is less than or equal to type. You are going to take the solution points towards the origin. All the points which come under this line are nothing but the solution points satisfying the first inequality. Accepted? Right. Coming to the second inequality, 6x1 plus 5x2 is greater than or equal to 60. I am taking equal to 60. So you give me the input points here. What are the points we are going to take there? Right. So the points are 10, 0 and 0, 12. So if you draw the line, this will be, say this is 10 and this will be 12. So it is greater than or equal to type. You are going to take the points away from this line. Actually, feasible region means we are checking the set of points which are satisfied by both the inequalities. So did you find any such points here satisfying these things? Say, can you find at least one point which satisfies the two inequalities? No. So in such case, we say that the LP problem has no solution. Technically, we say that it has infeasible region or infeasible solution space, you can call. So in an observation, we can say that whenever the intersection of the inequalities is not possible, they are away and they are apart in the intersection part. So we can say that we have the choice of getting no solution, and we call it as the infeasible region. And this is the infeasible region, you can say. Accepted? Any other queries with regard to this problem? If you are clear with this, then I go to the next model of graphical method problem. Right. Thank you. So can I erase this? Fine. So the next thing I want to take is maximize z equals to 5x1 minus 2x2 subject to the constraints x1 less than or equal to 2, minus x1 plus 2x2 is greater than or equal to 4, and x1 comma x2 are greater than or equal to 0. This was the problem I am going to take. So as usual, let us draw the graph here. So x1 less than or equal to 2 means, if you take this is x1 and this is x2, we are going to get the straight line like this. And all the points should be coming towards this. Accepted? Any queries? Right. So coming to this inequality, you take minus x1 plus 2x2 equals to 4. So please give me the points here. The points what we are going to take? Minus 4, 2. So this is the point minus 4 comma 0, and it was the point 0 comma 2. It is going like this. Accepted? So what happens? The inequality is of the type greater than or equal to. So the two inequalities satisfied feasible region is this thing. Now here, one observation is the solution space is unbounded. It is not a closed polygon. So usually the maximum solution will be obtained at the corner points. Since the feasible region should be taken care in the first quadrant only, on the look we can say that this is one point 0 comma 2, and the intersection of these two is nothing but 2 comma 3. these two are the points usually we consider. So if you substitute these two, what will be the solution? The value of z. So for the first one, it is 1. If substitute the second point, it will be 1 is maximum. Is that 4? Yeah. So if you substitute 0, 2, the value will be -4. Am I correct? Right. So which we do not consider. And if you substitute 2, 3, the value will be 4. 4 is the maximum. Now the question arises here is, if you keep on moving like this, even though x1 coordinate is fixed, 2 is fixed, you cannot take the maximum value for x1 as 2, more than 2. So if you take any point for x2, as you are goes on increasing, it will be more than 3. Now the question is, will you get the maximum z as infinite or not? Are you getting the concept? Because the solution space is unbounded. Let me say, in the previous class, we have taken the example that we have a solution space formed like this, and there the solution space is unbounded. So what happens if we keep on taking points here? Since the magnitude of the points goes on increasing, the coordinates, you have the possibility of z being infinite. Accepted? Fine. Now I am asking the same question that since the solution space is unbounded, yes, since the solution space is unbounded, since x1, x2 must be greater than or equal to 0, right? So if you keep on increasing x2 value, since the objective function contains minus sign for x2, so you will get the value of minus infinity. Accepted? Right. So the thing is, the maximum value for z is 4. So this example I have chosen that even though the solution space seems to be unbounded, you will have the chance of getting maximum z of having the optimum solution 4 in this case. That is my whole ideology. So you cannot always say that if the solution space is unbounded, the maximum z also becomes infinite. You cannot say. Here it is infinite. We are considering the maximization of z, not the minimization, right? So for maximization, you can have the possibility of getting maximum z even though the solution space is unbounded. And we are taking the criteria by observing the objective function. Clear now? So in the objective function, if you have the negative coefficient, you may have the possibility of getting the optimum solution even though the solution space seems to be unbounded. That is my idea of bringing it for you. Yeah, let me say, what is the objective of this problem? Maximization, right? That means I am going to get the maximum profit. In this case, the maximum profit is 4. Accepted? Fine. So you cannot take the negative profit. Minus infinity we won't consider. Here you have obtained the maximum solution for the LPP. Let me take the case. Suppose if it is positive for our consideration, right? So what will be the maximum z here? So one solution for z is 4, at the point 2, 3, but you cannot give guarantee that if you keep on taking points in this solution space, you may have the possibility of getting maximum profit very huge. Accepted? So here I am saying that if the objective function contains the negative sign here, this thing is not possible even though the space seems to be unbounded. That is my idea. Is it fine now? Thank you. If it is clear, I go with the next solution, next problem. Fine. So the whole thing which we are doing under graphical method is nothing but the objective function is given and set of constraints are given. You are simply drawing a graph. So on observing the graph, what type of solution we are going to find for the given LPP, that is actually what we are discussing here now. Now see, let us take the problem maximum z equals to 20x1 plus 10x2. Subject to the constraints 10x1 plus 5x2 is less than or equal to 50. 6x1 plus 10x2 is less than or equal to 60. And 4x1 plus 12x2 is less than or equal to 48. So let us draw the graph for this LP problem. You are going to give me the values. So for the first one, what are the points we are going to take? Yeah. So 5, 0, 0, 10. So this is 5, 0, and say this will be 10, 0, 0, 10. So for the second inequality also, you please give me the points, right? So 10, 0 and 0, 6. And for the third one, 12, 4, right? So it takes a thing more. I will take like this. Since all the inequalities are of the type less than or equal to, this is the only closed region which we are going to consider, which lies below the 3 inequalities we are going to consider. Accepted for the feasible space to everyone? Right. So this is the point which we consider 0, 4. This is the point 5, 0. And give me the intersection of these two lines obtained by the first and the third. Are you getting the ideology? Right? Can you give me the intersection points there? They will come under fractions. 0, 4, why we are considering, right? It must satisfy the 3 inequalities. Will it satisfy? Can you check? So we are going to draw the scaled graph. For every LP problem, x1, x2 is greater than or equal to 0 is by default taken. I stopped specifying this because it is obvious for every LP problem. the non-negative restriction. There is no need to specify that separately. Fine. Whatever the problem we are solving under a graphical method, it is obviously considered x1, x2 greater than or equal to 0. Thank you. So if you solve the equations 10x1 plus 5x2 equal to 50 and 4x1 plus 12x2 equal to 48, this intersection point will come as per your inputs. The point is 18 by 5 and 14 by 5. Now the question is, let us substitute these 3 points in the objective function. Right? I want the session to be interactive so that I can understand we are going in a streamline. So if you substitute the point 0, 4, the z value will be 40. Accepted? Right. So if you substitute the point 10, 0, sorry, 5, 0, what will be the value? 100, right? So if you substitute the point 18 by 5 and 14 by 5 in the objective function, what is the value? 20 into 18 by 5 plus 10 into 14 by 5. Right, 100. So from this, we can say that the maximum z value is nothing but 100. But it is achieved at 2 distinct points. Accepted? Yes or no? So the conclusion here is the given LP has optimal solution which is not uniquely determined. It is given by 2 different solution sets. The solution points, one is 5, 0, another one is 18 by 5, 14 by 5. Such type of LP problems are called several optimum or multiple optimum or alternate optimum. So if you talk of the real life situation, you can choose the either of the thing to get the maximum output. So in solving the real life situation, we have 2 methods or 2 ways to solve that real life situation. In such way we can interpret that. Fine. So here the solution is existed. We have found the maximum value of z and the solution is not unique. It is obtained in 2 ways. At the 2 points it is obtained. It has 2 different optimum solutions. Not different. One optimal solution with 2 different choices. Clear? Any questions, please? Right. So let me go with the other one. So let us take that the following LP. Maximum z equals to 100x1 plus 50x2 subject to the constraints 4x1 plus 6x2 is less than or equal to 24, x1 less than or equal to 4 and x2 less than or equal to 4 by 3, where x1 comma x2 are greater than or equal to 0, which is obvious. Fine. So let us draw the graph for it. Exactly. Now I am going to discuss these things with regard to the limitations of the simplex and LPP after discussing a problem. Fine. Right. So taking care of the first inequality, you please give me the points. What are to be taken there? Say. Are you solving that? Right. So 6 comma 0 and 0 comma 4. It is of the form less than or equal to. Right. And here it is x1 less than or equal to 4. So straight away we take like this. And that is x2 less than or equal to 4 by 3. It is 1.3 something. We will draw the line like this. Accepted to all? Right. Now what happens? You can observe that usually in the polygon region, we get an intersection point because of two lines, isn't it? Whenever two lines intersect, then only we get an intersection point. Here what happened? You got the intersection point by means of three lines. If you draw it using scale and measure it correctly, they all meet at one single point. So such kind of problems, they will have the optimum solution, no doubt at all. You can find the maximum z. Let us find that also. So this is the solution space you are considering here. You can have the respective points. 4 comma 0 here. 0 comma 4 by 3 is another one. Intersection of these two. So if you substitute the respective points in the maximum z, let us calculate those values also. So one value for z is 400 if you substitute the point 4 comma 0. So the another one is, if you substitute 4 by 3 here, it will be 200 by 3. So around 66 point something you will get. And if you substitute 4 comma 4 by 3, you will get the maximum value of z as 466 point something. Now, among the 3 points, while observing the graph, we can say that maximum for z is achieved. So for the given LP problem, optimum solution is existed. Now the question is, if you take the real life situation, this type of situation we call it as degeneracy. So while doing the simplex method, problems solved by simplex method, whenever a problem contains degeneracy, we have to build the number of iterations more. So it takes computation time more compared to the regular problems. But at the end, you will achieve the optimum solution, no doubt at all. It is just like repeating the steps one after the other for certain number of stages. Clear now? So on the whole, the total discussion on graphical method is mainly concerned about, for today's session, as far as in the previous class we have discussed what is meant by the feasible region and optimum solution. In today's class we discussed that even though solution space seems to be unbounded, you will have finite optimum solution. So optimality will be achieved. One graph we observed that there is no solution at all. We call it as infeasible region. There is no intersection which is not at all possible there. One graph we observed that it will have multiple solutions. So optimality is reached by multiple values. And the other one is the thing which we have discussed, we call it as degeneracy, where the intersection is obtained by means of three lines. Please understand that all the three lines must intersect at one single point. Please understand the context that degeneracy means the point of intersection is obtained by means of three lines, more than two lines exactly. So in the previous case, if at all a solution is obtained by means of intersection of three lines and more, that situation we call it as degeneracy. Fine? Right. So in the previous problem, we have three lines intersected, but no point is formed by means of all the three intersection. The intersection point is formed just because of only two lines, not of three lines. Such situation we call it as degeneracy. Clear now? Exactly. Three lines intersecting at one single point, we call it as degeneracy. So two lines intersection is nothing but regular point. The corner point we take and substitute in Z. Clear now? So these are the variations under graphical method. The significance is nothing but, so if you take a real life situation, it is nothing but a tie will come to decide the decision. Suppose I am the production manager. I have several options, among which I have three choices made which are possibly good. Now what happens? All the three choices are yielding the same result. Now the question before me is which choice I have to go, right? Picking up of which choice. All are equally good. So it is purely the decision based on me only. Which choice appears to be or seems to be good for my conscience, I am going to take that. That is called degeneracy. Because in a real life situation, you cannot try one after the other all the time, right? You have to take only one decision at one time. You cannot try with all the situations. Accepted now? Fine. So if the concept is clear for everyone, if you're interested, I will give several graphs at the end of practice session or on the completion of this particular topic, so that you will have a good understanding. Then I am going to shift my discussion for simplex method. Shall I? Right. In the meanwhile, if you have any other questions or doubts, you can ask. Usually the weightage for graphical method is only 10 marks in the examination point of view. Just drawing the graph and finding the optimal solution. You cannot expect a more complexity in that. So let us go with simplex method. So in this discussion, so for drawing graph, as far as my thing is concerned, if you want to plot the points correctly, that seems to be good rather than the freehand. Freehand is accepted, right? Because some of our students submitted the test series with freehand. We have accepted that. But if you have a scaled one, that looks good. Because whenever you have the case of degeneracy or multiple optimum, there you miss. Right. So coming to simplex method, I concentrate mainly on how to construct the simplex table, solve the problem and retrieve the solution. And in a simple nutshell, I will give the idea that if we have the system Ax equal to B, X is determined by A inverse B, accepted? Right. So we have the Gaussian elimination method for finding A inverse. If we have the matrix A, you are going to bring the identity matrix here of the order required as per the problem. So by applying suitable row operations, you will get the inverse part here and A will be reduced to the identity matrix. Accepted? So this kind of phenomena we are simply following under simplex method. The outline of simplex method is just like that. Fine. So we are building a table having the constant matrix on one side and the identity matrix on the other side, and we are doing the operations on it so that we are going to get the respective inverse matrix. Don't feel that it is exactly the inverse, it is just like that, the obtained phenomena. Fine. Now let us go with the problem. So while solving a problem using simplex method, there are many things to be observed. I am going to take one after the other. So without any hesitation, I am going to take the first problem of the previous class lecture where I have started. By means of simplex method, we are going to solve it. So the problem is maximum z equals to 6x1 plus 8x2 and subject to the constraints 5x1 plus 10x2 is less than or equal to 60 and 4x1 plus 4x2 is less than or equal to 40. This is the problem. First we have solved using graphical method and its solution is, I think it is 8, 2. Can you check that once on your end? Say yes or no? Fine. Now we are going to get the same solution here by means of simplex method, right? So how to construct the simplex table? So first of all, we are writing the LP problem in canonical form. Since these are inequalities, to balance the inequality, I am introducing some variables. So I say that 5x1 plus 10x2 plus s1 equal to 60. And similarly, 4x1 plus 4x2 plus s2 equal to 40. These are called slack variables. S1 and S2 are called slack variables. Is that clear? So the objective function will be written as maximum z equals to 6x1 plus 8x2 plus 0s1 plus 0s2. Why I have taken the coefficients as 0 means because we are going to find the solution for x1 and x2, not for s1, s2. So it won't have any effect even though s1, s2 values are existed on the objective function. Clear? Any questions, please? And one fundamental thing we need to observe here is whenever the objective function is of maximization type, right? Whenever the objective function is of maximization type, all the constraint must be in the form of less than or equal to. So every constraint must be of the form less than or equal to. Occasionally, we have the possibility of constraints having mixed inequalities as well as equalities. Such type of problems we are going to discuss on the later thing. So coming to the part why I have taken 0 here. See, if you find the values of S1 and S2, will the objective function get influenced or not? Because the LP problem is based only on X1 and X2, not on S1 and S2, right? That's why I have put the inequalities as 0 and 0, the coefficients in the objective function. The objective function is based on X1 and X2, not on S1 and S2, right? Right. Now, how to build the table? Now, first of all, we write the coefficients in the objective function on the top. So 6, 8, 0, 0. Is it visible on the top for you? Right. And the corresponding variables x1, x2, s1 and s2. Now, the table contains the basic variables a variable is called basic if in the constraints what you have written, its coefficient must be 1 in one constraint, in the other its coefficient must be 0. So coefficient must be 1 in one condition, in all the other conditions its coefficient must be 0. Such variable is called the basic variable. So here, if you observe these things, S1 and S2 are basic variables, because here S1 has coefficient 1, here its coefficient is 0. Accepted? Yes or no? Right? So let us write the corresponding coefficients here, S1 and S2. So if you take the first equation, 5, 10, 1, 0. Am I correct? X1 coefficient, X2 coefficient, S1 and 0. And for the second, here you have 4, 4, 0, 1. Now you can visualize the matrix here. This is matrix A and this is identity matrix. Accepted? Fine. Now, here I got the solution. The right side constraints, what we have is 60 and 40. And here we take the coefficients of S1 and S2 as 0, 0, which are taken in the objective function. So please check on the tabular form what I have written. So these are the basic variables. These are coefficients of the basic variables. These are objective function coefficients, corresponding variables there. This is the matrix form what we got, and the condition values are placed here. Clear to everyone? So different textbooks will have the different form. The tabular form is fixed. Maybe solution, apart from writing here, they will write the solution here. That may be the difference. But every table contains these columns. That is fixed. Fine. Now let us calculate the profit, that is ZJ. So let us multiply the values, that 0 into 5 plus 0 into 4. Because in the objective function, we multiply with the corresponding coefficients, right? These are the cost coefficients. So it will be 0, again 0, 0, 0. Accepted now? Initially, the values are 0. So if you multiply and sum up, you will get 0. Clear? Now I am going to take the difference between Cj minus Zj. This is Cj and this is Zj. I am calculating the difference between these two. 0 into 5 plus 0 into 4, the sum is 0. Like that I have done for every row and every column. Right? Now I am taking the difference of this Z value and the corresponding cost coefficient value. So this will be 6 minus 0, 6. This will be 8. This will be 0 and this will be 0. So I am giving the part of solution how to proceed and how to get the table and how to solve the problem. I am mainly focusing on the problem solution part, right? Now, please understand that if Z is profit, C means cost. So C minus Z indicates the difference between these two. Accepted? So optimality means we should have the maximum value of Z. It means that the difference between these two must be minimum, Cj minus Zj, right? So we are building the table that if you calculate Cj minus Zj, all the values must be less than or equal to 0 for maximization problem. This is the checking condition. So if you calculate Cj minus Zj, all the entries here must be less than or equal to 0 for getting maximum Z value. Since at the first stage it is not at all satisfied, so we go with the most positive one. Why? Because here maximum variation occurs between the profit and the cost. So if you replace this so that the difference between these two will be minimized. Accepted? Are you getting the idea or not? Say yes or no. Right. So just imagine that if you are doing Gaussian elimination method in matrices, we are checking a pivot element for doing row operations. So it is just like selecting a pivot element. So where to start with the pivot element, it is just like that. As we do, R2 tends to R2 minus some value into R1 like that. This value we call it as the pivot element. In Gaussian elimination, we are just proceeding like that. So now tell me where you have the doubt. The thing is, after finding Cj minus Zj, if all the values are less than or equal to 0, we confirm that the solution is optimal and the values taken here at the end, the solution part, the values taken here are nothing but the actual solution for the given LP. If it is not that, then among the values, we go with the most positive value. So this column we are going to select, it is called as key column. Because maximum difference is there, right, between the profit and the cost. So we have to minimize that. Otherwise, we cannot get the maximum value of profit. Right? If you just take that, this is profit, this is expenditure. If you want to get maximum profit, expenditure should be minimized. That means the difference between these two must be minimized. So wherever you get the maximum difference, that should be minimized first. Accepted then? Right. So now what happens? Here we calculate ratio. So these solution values are divided with this corresponding key column values. So 60 by 10, it is 6. 40 by 4, it is 10. Fine. Occasionally, we have the ratio will be negative and sometimes undefined also. Those things we won't consider. Always we take it as a positive number, sometimes 0, the ratio. So whenever negative value comes or undefined value comes under ratio column, we won't consider that value. Now what happens? After finding the ratio, to select the pivot element, we have to go with the row. Which row among the two I should select? So which ratio is minimum, I should go with that row. So since 6 is minimum, so if you get the intersection, this is the pivot element. So 10 is my pivot element. We always go with the minimum ratio. Fine. If anybody has any doubt with regard to the problem specification and procedure, you can ask. I will repeat that thing again. Building the table. Ratio of this solution values with the column you have selected. 60 by column value, 40 by the column value, the column which you have selected. Why ratio is minimum? Just say, suppose my objective function is just like distribution of goods. So minimum number indicates that this much minimum number of goods I can distribute to all so that all the constraints cannot be violated. In the practical situation, you can think like that. Accepted. Right. Now, I am going to perform the row operation. So I am going to construct the subsequent simplex table down here. So again, please understand one thing, that this is the row pattern initially you have taken, S1 and S2. So the same thing will come here. So after selecting the pivot element, I am replacing the basic variable S1 with the X2. So this is X2. Its corresponding coefficient 8 is written here. S2 is taken as it is with the coefficient 0 as it is. Clear to all? How the replacement has done? Right. So here what I am doing, the pivot element is appeared with regard to the basic variable S1. So I am replacing S1 with the decision variable X2 here, and the corresponding coefficient is taken here. And this remains as it is in the down. Fine. Right. Now, this is the pivot element. So this entire row is divided with the pivot element. So 5 by 10, that is 1 by 2. This will be 1, 1 by 10, 0, and it is 6. Any questions? How the row is changed? So based on your inputs, I am going to move further. Right. Now I am going to perform and modify this row. How I am going to modify? Now see, Let us write the row first here. Now see, this is the pivot element place earlier I have considered, because my intention is I want to get the identity matrix. So if this is the value 1, the value before this and below this must be 0, right? So if I want to make this 0, how should I perform the operation? So R2 tends to R2 minus 4R1, because 1 is standard here. Accepted? Any doubts for anybody? Because this operation is very important in building up the modifying rows. So what happens? This is row 1. I am performing the operation as R2 tends to R2 minus 4R1. So from the second row, I am subtracting every element of this row by multiplying with 4. So without any ambiguity, I will write like this. The thing is 4, 4, 0, 1, 40. This is my row 2. So I will write 4R1. This will be 2. 4. 4 by 10 is nothing but 2 by 5. Again 0, 24. Now I am subtracting the values. What is the result? 2, 0, minus 2 by 5, 1, 16. Accepted? How I have modified the row? Right. So I am going to write the respective values here. Sorry. Is it clear for everyone how the first row is modified and second row is modified? Yes or no? Right. Now again I am doing the same procedure, calculating Zj as well as Cj minus Zj. So let us do this. This value is 4, the Zj value. Again 8. Again 8 by 10 means 4 by 5. Again 0 you have. Again 48. So that thing is not at all required. The solution part, there is no need to consider. You leave that. Again calculate Cj minus Zj. So the value is 2, 0, minus 4 by 5, 0. You can ask your questions how it is calculated if you have any. If it is clear for everyone, then I go to the next level. Fine. Now again check the last row, the decision row, Cj minus Zj. So is all the values in this row are less than or equal to 0? No. So that optimality is still not attained. Now here I will check what are the values which are positive. Among the positive things, I should go with the most positive one. So here this is 0, this is negative, this is 0. There is no need to consider them. This is the only positive thing remained here. So I should go with this column. This is my key column. Right. Again the same thing comes. So you are dividing the solution values with these key column entries. So 6 by 1 by 2. Will that be 12? And 16 by 2, it will be 8. Accepted? So I have obtained the ratio in which the minimum ratio is 8. So I am going with this row. So if you found that, what is the pivot element? 2 is my pivot element. Any questions now? If anybody has. Are you following the idea or not? 12, 8. Six divided by 1 by 2, 16 divided by 2. Fine now? Right. So again, since the space is not here, I am going to build the next table. So first of all, you have to identify that I am going to replace the variable s2 with regard to the decision variable x1. So what is the coefficient of x1 here? 6. So that must come here. So the table will come with the values as earlier you have x2, now you got x1, its coefficient is 8, its coefficient is 6. So while building the table, always first we go with the pivot row. Once you're done with this, then based on this row, you are going to do other row operations of the other table. Fine. So since the pivot element is 2, this entire thing is divided with 2. So how it comes? 1, 0, minus 1 by 10, 1 by 2, and this is 8. Accepted? Any questions to anyone? Or are you comfortable with this? I need a response from your side, how I am building the construction table. So minus 1 by 5 here. Say. Accepted all. Fine. Now I am going to get this modified row. Now see, this is the thing I got. So this thing is replaced like this. So based on this element, I am going to make it as 0. How I have to perform the operation? How I need to perform the operation? So let me write the things. If you have a little doubt here, I will make space. So this is the row which I got. Now tell me, the element before this one must be 0. Right? So how it is going to be changed? R1 tends to R1 minus 1 by 2 R2. Accepted all? Any queries for anybody? The thing is, based on this element, I am going to make all the values below to this. Just like Gaussian elimination, the row operations which you perform. So since the time is running out, straight away I will write the solution part for you. It will come as 0, 1, 1 by 5, minus 1 by 4, and there you got the value as 2. So let us calculate Zj and Cj minus Zj. The values are going to come as 6, 8, and then 2 by 5, 1, and the value is 64 here. So if you go with Cj minus Zj, 0, 0, minus 2 by 5, minus 1. Now see, all the entries in the row Cj minus Zj are less than or equal to 0. Here, 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 and here. Therefore, optimality for the given linear programming problem is achieved. So there is no need to build further tables and do more. Now what is the solution? So from the solution column, the value of x2 is 2, the value of x1 is 8. So 8 comma 2 is the solution, and the maximum z value is 64, which you have obtained from graphical method also earlier. You can cross check that. Accepted. Now this is the way to construct the simplex table and solve the problem, and checking the optimality condition. The thing we need to remember here is, for maximization we check for less than or equal to 0. For minimization we check for greater than or equal to 0. So if you consider Cj minus Zj, if you consider difference in reverse, some others also mentioned like that. If you consider Zj minus Cj, always we take the value as greater than or equal to 0. Fine. So any queries with regard to the optimality checking condition, building up of simplex table and solving the problem to anyone? Or is that giving a confusion to you? Since this is the only way of simplex method. The method is defined like this only. Definitely, I am going to take more number of problems on this, not only one. Fine, because I want to take the maximization concept, minimization. Ratio for minimization is also same thing. Always ratio will be taken as minimum only. Right? So is this the table and solution clear for everyone? If so, I will go with doubt clarification procedure. Maximum marks is 20 as and when a question is posed for you. Right? Basic variables, right? Shall I erase the board first so that we can have the good discussion? Thank you. I think all of you have noted the solution, how it came. Now I just draw the outline. So the objective function coefficients are written here. And the variables are written here. So you have the solution and you are calculating the ratio. So now this is some constant, this is some constant. Please understand, if I have taken an LP problem for maximization and we are taking less than or equal to inequalities here. So to balance the inequality, I am introducing slack variables. Accepted? So if I have two constants here, I will get two slack variables S1, S2. If I have three, I will get three slack variables S1, S2, S3. Accepted? These slack variables, I am calling them as the basic variables because S1 is presented only in the first constraint, not in the 2 and 3. So what happens, you will get an identity matrix setup in the table. So this is some number here, some number 1 and 0. This is 0 and 1. You have the identity matrix setup. So you are performing row operations on the identity matrix. So these S1, S2 I am calling as basic variables. The definition is given as a variable is called basic if it has coefficient 1 in one condition, in all the other conditions its coefficient is 0. Similarly, S2 in one condition its coefficient is 1, it is presented, in all the other conditions its coefficient is 0. That is about the basic variables. Clear now? Because S1, S2 are presented in only one inequality, not on the other. Right. Now what I am doing, the coefficient of S1, S2 obviously 0. They are taken here. Now I am calculating Zj and Cj minus Zj by simply multiplying these coefficients with corresponding value. I will get some numbers. The optimality condition is all the entries of Cj minus Zj must be less than or equal to 0. So the top value minus this, top value minus this, top value minus this must be less than or equal to 0. If it is satisfied means optimality is achieved, there is no need to go for the procedure. Further extension is not required. If not, it is not less than or equal to 0 means in these values some of them are positive. So you go with the most positive value, which I am calling it as key column. So let me say if this is 12 and this is 10, Cj minus Zj, remaining values are negative or 0. So among the two positive values, 12 is the maximum positive value, so I am selecting this column. Accepted? Any doubts in selecting the column? I am calculating Zj, I am calculating Cj minus Zj. In that, among the positive values, I am going with the most positive one. Now what happens? I have the column values. Here I have the solution values. I am dividing this solution with this column value. I got a ratio. Among the ratio, I am always taking the minimum ratio because this is the minimum criteria to fulfill all the constraints. That was the logic. So that the corresponding row will be highlighted. The pivot element is taken. Rest of the procedure you know how to build the table. Is it clear for everyone? Yes, always we take minimum ratio. That's all. We don't go for maximum ratio. Always we go with the ratio with minimum. Whenever you have a negative ratio comes here, we don't consider this thing, we consider only positive thing. Because negative distribution is not practically possible in real life situations. I think the procedure part is clear for everyone. Say. Right. So let us wind up our discussion here on building of simplex table. let us go with the limitations of simplex table as one of our friends asked. It is just like 2 or 3 points I am going to emphasize. It is just for your understanding. Can I continue or let us stop here? Please tell. Right. Just hold on a second. I am going to write the limitations of simplex method. Just for a minute. Right. Now see, the first thing for all the variables in the simplex problem or linear programming problem are directly proportional. In other words, they are linear in nature. That means either decrease or increase in one variable results the solution also in the linear way, the way it is increasing linearly or decreasing. But practically in real life situations, we cannot get such type of linear increase or decrease. Sometimes there are sudden rise or sudden down in profit while going in a business. Accepted? That is one. Second thing is, as we have observed, if the results are numbers, it is okay. If the results are fractions, suppose I am doing a job problem that how many number of persons are there, how many number of jobs are there. If x1, x2 values, take that 4 by 3, 5 by 3, it is not practically distribute the persons in fractions. So if the solution is not in fractions, it is good. Otherwise, it has a problem. Accepted? That is one limitation. Another one is always the simplest problem, I mean the linear programming problem has only one objective. That is either maximization or minimization. But practically, if you take a real life situation, there I have two objectives to be satisfied. There, this method won't work. That is one limitation, we can take that. Clear? And one more thing is, as we have discussed, there are different solutions like unbounded, feasible, multiple optimum solutions. If you have such type of thing, you cannot decide. So in the other way, you can say that you cannot get always a fixed solution for the given problem. Sometimes it gives the solution, sometimes it won't. So these are some of the limitations for this simplex method that we can take into consideration. And the most important thing is, it is very difficult to compute this much number of tables. The fundamental thing takes more time to construct all these things. There is the fundamental disadvantage. If number of variables are more, it takes more times and more tables to construct. At the most 3 iterations we take. Once you get addicted to this, at most time you can take 20 minutes to solve a problem. That's it. 20 minutes at the most to solve a problem. Right? So let us wind up our session here. Tomorrow I take again simplex method and more problems on it. Fine. So initially it takes a time for you to set for this method in building the table. That is the only difficulty for everyone. Accepted? Yeah. since you are hearing for the first time, how to build a table is a question mark for you. Later you are going to get very little idea on this. Right? That's all for today. Good night to all.